What's up, guys? So this is the chapter 20 lecture notes, but first, before we get into chapter 20, something I'm going to address. The chapter 17 quiz. I've had several people email me about it. I know it was really hard. I plan on doing one of these videos where I recap all the questions in the chapter 17 quiz. Some of them are really hard, a lot of them were bonus. I think there were 10 questions total. Out of those 10 questions, I think I counted 4 of them as bonus. So as long as you made a 60, you technically made 100. So if you got 6 out of 10 of them right, you got 100. If you got more than 6 out of 10 right, you got some bonus points built in. But I am going to go through all those on one of these lecture videos like this. I'll hopefully have it updated over the weekend. These lecture videos take me probably 2.5 to 3 hours to record, even though it only takes like 45 minutes to an hour after everything's cut up and everything. And then it takes me out where I live, I think I've downgraded to 480p or 420p so that I could actually get it uploaded in a reasonable amount of time. It still takes me all night. I'll start it usually about midnight, and it'll take it till about 9 o'clock the next morning to actually upload. So it's a lot of process that goes into this. But I'm going to try to have that video up this weekend, so bear with me. But until then, hopefully all y'all are sticking to it. I know it's not easy doing the online stuff, but as long as you're pushing through and I'm seeing progress, that's a really, really good thing. I think most of you are getting it enough. Hopefully the chapter 18 quiz, I know some of you already taken it. Hopefully it seemed a lot easier to you. It should have been a lot more straightforward. So hopefully everybody's done well with it. I haven't gone in and checked that yet because there's still a lot of people left to take it. But let's get into chapter 20. Chapter 20 builds off of, I believe, chapter 17. So I know 17 seemed hard. In 17, what we found, let's see, what do we do first? In 17, we found confidence intervals for means, I believe. No, shoot. Now I'm going to have to edit this part. Or maybe I'll just leave it in. And so, anyway, chapter 20 builds on chapter 17, I believe. If you're worried about it being really, really hard, don't. It's really not that bad. It does build a little bit on chapter 18 too, because it uses some confidence intervals. And essentially what we'll do, I think it's 17 and 18 kind of build together. One of them was confidence interval proportions. This one's confidence interval means. 19 and 21, I clumped them together because what we look at is hypothesis testing. And once you've done confidence intervals for means and confidence intervals for proportions, the hypothesis testing is really, really pretty easy, and it's pretty much the same thing for proportions or means. It's just a matter of which button to hit on the calculator. So you'll get a lot of this together. Other than that, let's get right to the material, because the shorter I can keep these videos, the less time that I have to waste my Wi-Fi here at my house. So let's get to it. Like I said, chapter 20, confidence intervals for means. The confidence interval for the true mean, that means mean, that's standard deviation, you should know that by now. For the true mean, when the standard deviation is known, is given by confidence interval equals x bar plus or minus z star times sigma over the square root of n. This is true regardless of sample size. Case 2, the confidence interval for the true mean when the standard deviation sigma is not known, but the sample size is greater than or equal to 30. So we either know the population standard deviation or we don't know the population standard deviation, but we have a sample size that is greater than or equal to 30. So in this case, we'll wind up using the sample standard deviation and essentially do the same thing. Now with large sample sizes, the standard error does work pretty well for following normal distribution. Small sample sizes, not so much. But we have a way to combat that. So here we're using a z-star, which is just your z-score that you can find from the z-table if you really want to do it by hand. In case 3, when we have really small samples, it says the confidence interval for the true mean when standard deviation is not known. The sample size doesn't matter. Okay, here we have the confidence interval equals x bar plus or minus t star times this s of x, sample standard deviation, over the square root of n. So using the student t distribution, the distribution or the size of the sample doesn't matter and can be abnormally small. It can actually be really small. It can be small as 3 or 4. I guess you could make it as small as 2. I don't know why you would make it that small, But even 3 or 4 is really, really small. But you can use this student t distribution with really, really small sample sizes. Okay, the student t distribution. That's what we're going to get into next. The Gaussian student t distribution is always bell-shaped, but the details change with different sample sizes. When a sample size is very large, the model is nearly normal. So if you're using the student t distribution or the t distribution, and if you use it with a really large sample size, it's going to wind up being approximately normal. So I'm going to show you some ways to do this on the calculator. Make it really, really easy, as long as you know what you're doing, know which buttons to press. So when sample sizes are really big, a lot of times if you were supposed to use, if n is greater than 30, you're supposed to use the z-star, so you're supposed to use a regular normal distribution. But if you chose to use the student t distribution and n is greater than 30, typically what happens is the numbers are so close together that it doesn't really matter. Now they're not going to be exactly the same unless you get really, really large sample sizes, but they're generally so close that it really, you couldn't tell the difference because they're both approximations either way. So when the sample size is small, the tails of the distribution are much heavier than the normal distribution. It forms a whole family of related distributions that depend on a parameter known as the degrees of freedom, which is n-1. Now, if we were to do all this by hand, using the student t distribution by hand, you would really, really, really have to know what the degrees of freedom are in order to do it. In this class, with our given situation, we're going to do it all on the calculator, okay? That's the easiest way to do it. I can show you the buttons to hit on the calculator. We can interpret what we're getting from the calculator. I'll kind of work us through some of the process here on the board so that you can kind of get it too. But I'm not going to make you work through the student t table and worry about the degrees of freedom. The calculator will handle all that when you run the student t distribution. So if we move on down, this is a very good visual, okay? And you can probably see it much clearer on your PDF than you can looking at my YouTube video here. But the z distribution, which is the standard normal here in this bluish color, this light bluish color, maybe a tealish color, you could see it comes up, it goes down, the tails get really, really small. Now the t distribution, when n is close to 30, you notice it's not that far away from the z distribution or the standard normal. It's actually pretty close, but the tails are a little heavier. It's kind of more spread out a little bit. The t distribution, when n is smaller than 30 though, so when you have really small t's or really small n's and you're using the t distribution, what happens is these tails, what we're calling these tails, are these pieces on the ends, they get a lot larger. So the smaller t is, the larger they get. So that kind of gives you a visual of what happens. So when we use the t distribution and n is a lot greater than 30, so it's a really big one, it'll actually pull this distribution on up and it'll get really, really close to being the standard normal. So close that you really can't tell the difference. But around 30, there's a pretty noticeable difference. Below 30, there's a really noticeable difference. Above 30, it starts to get really, really close to the normal distribution. Okay. Alright, so how do we find a t-score on the TI-84 calculator? Okay, we can use the second distribution button, we can do inverse t, we can type the area in and the degrees of freedom in, and figure out the t that we need. Okay, there's a much simpler way to do this, and because of that and because of our situation, I'm not going to have you finding the specific t-score on your calculator. Now I might do an example by hand here in a little bit where we use the t-score, but like I said, what we're going to do, the process we're going to go through in our given situation with all of us being out of school and me not being able to be really hands-on with this and show you and walk you through in class how to find this, because it can be kind of tricky. What we're going to do is we're going to focus solely on the calculator commands that will get us straight to the answer rather than the little pieces and piecing it together by hand. Okay, so the information's here for you if you want to dig further into it, but I'm going to show you the way on the calculator here in just a little bit so that we can do this really, really simple. Now, like I said, we're not going to find standard deviations by hand. We did that, I think, once earlier this semester. The calculator does this all for you. If you're looking at the standard deviation, a normal standard deviation would be S equals the square root, and you've got all this stuff here. The only difference with the t-distribution, because your sample size is typically small, we don't know the true population mean, we estimate it with y bar. However, in doing so, the sample standard deviation is based on a sample mean. It's going to be smaller than normal. So in order to fix this, instead of dividing like we do with n here, if we know the mean, we divide by an n minus 1. Like I said, we're not going to have to do this by hand. The calculator's going to do it all for you. You don't have to know these formulas. Don't feel like those are something you need to memorize for this class. Okay? Now, I typically give a handout, and in that handout, what it does is it shows you the student t distribution. It's got the student t table in it. Like I said, we're not really going to worry about that. We're going to go straight to doing it on the calculator. I'm not going to have, I don't have student t. I can't go to your houses and give you a student t distribution for you to sit there and work through stuff with. There's a really easy way to do this on the calculator. So that's what we're going to do. So bear with me. Okay. All right. TI calculator. If sigma is known, what we're going to use is stat test z interval. If sigma is not known, we're going to use stat test t interval. And it's pretty much as simple as that. Okay. So what we're going to do here. All right. What we're going to do here, I've got a list here of examples. We're going to work through some examples so you can really see how this works. So our first example here says a survey of 68 hospitals yielded a mean of 108 patients per day in the ER. The standard deviation of the sample was 18. Construct a 90% confidence interval for the mean number of patients per day in a hospital ER. A says list all given quantities from the problem. B says is the problem or population standard deviation sigma given or known. C says are we finding a z interval or a t interval. D says compute the interval. E says what does this interval mean in the context of our problem. So we will go on the board and we will answer all of these questions. So kind of gotten a little into the example. We hadn't really answered no questions about it yet, but if you read through the answer choices or listened to me read through the answer choices, you notice we had to choose between a z interval and a t interval. Okay, that'll be an option in your calculator. You'll see it when I pull it up in just a second. How do I know when to choose a z interval and when to choose a t interval? So is the population standard deviation known? If it is, I use the z interval. If it's not, I use the t interval. Is n greater than or equal to 30? If it is, I use the z interval. If it's not, I use the t interval. It's pretty as straightforward as I can get it. Okay? If you know your population standard deviation, use the z interval. If you don't, use the t interval. That majority of the time, we'll go ahead and knock it out. Otherwise, sometimes you can tell by your n value as well. Remember, use your z interval. When n is greater than or equal to 30, use your t interval. When n is less than 30. So let's get back to the question. Alright, A says list all the given quantities in the problem. So if we look at our problem, there are 68 hospitals. So N is 68. Okay, those 68 hospitals yielded a mean of 108 patients per day. So our mean here equals 108. Easy enough. That would actually be an X bar mean as well because it's a sample mean. Standard deviation of the sample was 18. So our sample standard deviation was 18. Construct a 90% confidence interval with a mean number of patients per day in a hospital ER. So we want our confidence interval is a 90% confidence interval. Alright. Easy enough. Alright, so we got all our information here. B says, is the population standard deviation known? No. Our question didn't say anything about a population standard deviation. It said our sample standard deviation was 18. The answer to B is no. Do I use a z interval or a t interval? Okay. I use a t interval. Okay. You might say, well, my n is 68, that's greater than 30. So that leans towards Z. But if I don't know my population standard deviation, I use T interval. I don't know my population standard deviation. I know my sample standard deviation, therefore I use T interval. D says compute the interval. We've got to go to the calculator for that. So let's go to the calculator. Alright guys, so we're right here at the calculator. So, in order to get the Z and T interval, we're going to hit stat. And we're going to go over here to test. Okay, so stat, test. We're going to scroll down here to 7 and 8. Okay, 7 is your Z interval, 8 is your T interval. So we decided to use a T interval for this one. So I'm going to select T interval. Now it has data highlighted. We don't have data here, we just have the stats. So we have the information about the problem. Sometimes you'll have a whole list of information you can type in your list, and then you can use the data option. We'll show you an example of that in a minute. But go ahead and go over here, highlight stats, and hit enter, and it'll give you options to type the statistics from the problem in. So our X bar here was 108. Our sample standard deviation here was 18. Our N here was 68. And our confidence level here was 90%, so 0.90 or 0.9, either one's fine. If we calculate, what it does is it creates an interval for us. Okay, so just like that interval we created with proportions, it does it for population, or for sample and population means here as well. So what we're doing is we're just creating this interval, just like we did for proportions. Okay, it tells you all your, just reads back your information for you here. What we're really interested in is this first line right here with our interval. Okay, so that will be our computed interval. Now we can just answer the problem. I believe it wants it in a complete sentence. What does the interval mean in the context of our problem? So let's go to the board and do that. All right, so we computed D. We computed the interval. I just rewrote it up here. 104.36 to 111.64. I'm just going to reiterate one more time. We use the T interval here. It's pretty much as simple as if it tells you the population standard deviation, we use Z interval. If it tells you the sample standard deviation, we're going to use T interval. So population standard deviation, Z interval. Sample standard deviation, T interval. Okay? That's pretty much how you choose. To put it in a sentence, I am 90% confident that the true mean of patients per day in the ER is between 104.36 and 111.64. Okay? Do not round these to whole numbers. I know you can't have 0.36 of a person, but we're not looking at a person. We're looking at the average number of people. Okay? And the average can always be between numbers. Okay? So that's how you would answer it in a complete sentence. Number 2 here says a manufacturing company is making electronic parts for the space station. The parts they produce have a standard deviation of 14.9 micrometers. A sample of 32 of these parts gave a mean of 4.9 centimeters, which is equivalent to 49,000 micrometers. Let's construct a 90% confidence interval on the mean size of electric parts. Okay, so A says list the given quantities from the problem. B says is the population standard deviation sigma given or known. C says are we finding a Z interval or T interval. D says compute the interval. E says what does this interval mean in the context of our problem. Essentially the same A through E that we had before. Before we go to the board, I want to point something out and basically go ahead and answer B and C. We'll answer them on the board as well. B says is the population standard deviation sigma given or known. If we look through here, I find the standard deviation. The parts they produce have a standard deviation of 14.9 micrometers. Now, it doesn't come out and say the population standard deviation is or the sample standard deviation is. It just says the parts they produce have a standard deviation of 14.9 micrometers. And here's where a little, I say common sense, but here's where a little common or practical sense or reading between the lines sense, or however you want to think about it, comes in. Okay. If all the parts they produce have a standard deviation of 14.9 micrometers, that means their
population of parts has a standard deviation of 14.9 micrometers. So this is the population standard deviation. Typically when it's just the standard deviation of a sample, it'll be a little more clear. It'll say, it would have said instead, a sample of 32 of these parts gave a mean of 4.9 centimeters and a standard deviation of 14.9 micrometers. That's how it would have looked perhaps if it was the sample standard deviation. But here it's actually the population standard deviation. If it's the population standard deviation, okay, there's 32 of these parts in the sample, so the n is greater than or equal to 30. That means I'm going to choose Z interval. Now I'm going to go to the board and I'm going to repeat some of that again and put it all up. But I just wanted to go through it here when we had the problem in front of us.
So A, we just want to list the given quantities in the problem. So we figured out that our population standard deviation, sigma, is 14.9 micrometers. Okay. And that's kind of important, so let's write that. Okay, they took a sample of 32, so our sample size n is 32. It gave a mean, so a mean or an x bar, of 4.9 centimeters. Now we don't want to mix different units. We want all our units to be the same. So we've got micrometers in our standard deviation, and luckily enough our question converts the centimeters into micrometers for us, otherwise we would have to do that by hand. So I'm going to stick with micrometers. 49,000 micrometers. If you use this as centimeters and mix centimeters and micrometers, you're going to get the wrong answer. Got to have the same units. That's why I put this problem on here. Kind of highlight that. The only other thing we have in the problem is we want it to be a 90% confidence interval. So confidence level equals 90%. Okay, so is the population standard deviation given or known? Yes, it is. And it was 14.9. Do we use a Z interval or a T interval? We chose Z interval because we know the population standard deviation, and also another backup here, we've got an n that's greater than or equal to 30. Now D says compute the interval, so let's go to the calculator and do that real quick.
Right here, our calculator right here. We have decided to choose Z interval. So I'm going to do stat. Scroll right to test. Scroll down to Z interval, which is number 7. Okay, stats is highlighted. It wants to know our population standard deviation first. That was 14.9. It wants to know our sample average. Our sample average here, our X bar, is 49,000 micrometers. Remember, you got to keep the units the same. In here was 32. Confidence level was 90%, so that stays the same. I'm going to hit enter, and it finds our Z interval for us. So our Z interval goes from 48,996 to 49,004. So that would be our answer. Let's put it on the board and put it in a complete sentence.
So I've just computed the interval and put it on the board. We did that from the calculator. So the interval was 48,996 to 49,004. If I put it in a sentence, I'm 90% confident the true mean of these electronic parts is between 48,996 and 49,004 micrometers. Now, you're going to go out there and you're going to get a job. Most of you probably aren't going to use statistics in your job, but if you happen to use statistics in your job, what you're going to find is that your boss probably isn't going to want it in micrometers. He's probably going to want it in that original centimeters. So what you might have to do is convert back at the very end, which is what this blue part is. So what you could say instead is I'm 90% confident that the true mean of these electronic parts is between 4.8996 and 4.9001 centimeters. Okay, because if the true parts are in centimeters, standard deviation is in micrometers, because hopefully it's really, really small. You're sending it up on the space station, you don't want really that much difference. You only got so much play to play with. So you really want to be really, really close. So you might want to convert it back into centimeters to show how truly close you are, because these big numbers look further apart than these really, really small numbers. But it just depends on what your boss or what you're working in and what units you need it in. So be aware you might have to convert back and forth in real life. In this class, not so much. We usually keep it pretty straightforward.
3. A sample of 16 spools of 6-pound fluorocarbon line were taken from a large production batch at a factory. The tested strength of each spool is listed below. Assume the distribution of strength for this fluorocarbon line is mound-shaped and symmetric. Construct a 97.5% confidence interval for the mean strength of the spools from the entire batch. List all given quantities from the problem. Okay, so these are our samples of spools of 6-pound line. Okay, I'm going to show you how to type those in the calculator and then show you how to work through the calculator to get that data in so that you can use that. That way you don't have to find all those information separately by hand or on the calculator separately. You can do it all in one step. Because of that, I'm going to go ahead and type some of this in on the calculator. So when you get a big list like that, what you're going to need to do, put the calculator here, put this here, so that I can see both at the same time. So I've got my list here. You're going to hit the stat button. I know this is a really small cell on the right hand side, but just follow what I do. You hit the stat button, you hit edit, so that you can type your list in. Okay, so I'm going to type my list in. We've typed list in before, so you should be able to figure out how to get to your list, type it in if you couldn't follow what I was doing. So 6.2, 6.8, 7.1, this is the boring part, 6.3, 8.1. It doesn't matter the order you type the list in. All that matters is it gets typed in and you don't skip any. So if you want to go in a different order, that's perfectly fine. Try to make sure you don't type these incorrectly, because a small mistake on any one of these could mess up your overall answer. Like I said, this is usually the tedious part. .1, 6.3. Okay, once you have your list in, you're going to be able to take this list and you're going to be able to use it. Okay, now we need to look back at the problem and actually answer the parts of the problem so that we can figure out whether we're going to do a Z interval or a T interval. Right off the bat, I see that I'm using 16 spools of 6-pound fluorocarbon line. That right away starts porting towards a T interval. But what I also notice is that they don't give me a population standard deviation. So that concretely means that I'm going to use a T interval. Okay, I don't know the population standard deviation. And to back it up, my N is less than or equal, or less than 30. Doesn't have to be less than or equal to, it's just less than 30. 16 is less than 30. We need to use a T interval. So that already answers some of these first parts. So we can list all the given quantities from the problem. Honestly, in this case, this is the quantities of the problem. You got a 97.6% confidence. There's 16 spools, so your N equals 16. If you wanted to, you can find your mean and standard deviation from all of these. But we're going to go ahead and skip that part because our calculator is going to do it all for us, and we don't have to find all the individual parts. It'll actually tell us all the individual parts at the very end. We already said the population standard deviation sigma is not given or known. That's the reason we're going to use the T interval. So let's compute this interval. I'm going to go ahead and do it while I'm sitting here, and then we're going to put some of this information up on the board so that hopefully you can see it written down, because that works better for some people. So I've got my calculator here. I've got my list typed in. Just I'm going to do second quit. I'm not going to retype my list in, but I'm going to get back to it. Stat, edit. Here's your list. You can type it in. Now we've decided to use a T interval. So I'm going to do stat, my second quit first. Start on a blank screen. Stat, test. We're going to use T interval. Okay. Now I don't need to pull in stats anymore. I have data to pull in. So I'm going to highlight data, hit enter. Okay. It pulls my data from list 1. It should be, if you type your data in list 1, it should be on list 1. If you type your data in list 2, you need to change that L1 to L2. And you can do that if you need to. You can do second list, and it gives you the list of the lists here so that you can choose a different one if you need to. Mine's in L1. I'm sticking with L1. Leave the frequency at 1. The confidence level here. We've got a little different confidence level here. Our confidence level, I believe, if I remember correctly, is 97.5%. We can type that directly in. Just type it as decimal, 0.975. All I have to do now is calculate. And there it is. So our confidence intervals from 6.1585 to 7.3165. Our X bar here, it calculates that for us too. 6.7375. It even calculates our sample standard deviation here, 0.93 approximately. Our N is 16, which is correct. Our problem already told us that. This just further verifies it. And we can answer this problem in a complete sentence if we need to. I'm going to write all this on the board so that you have it all together for yourself, because some people need it written down and can't just get it from me talking. So, to the board we go. Alright, so like I said, I was going to put it on the board. N equals 16, confidence level is 97.5%, X bar equals 6.7375, and your sample standard deviation is 0.93. We actually didn't find this and this to the very end. We were just given the data set, but our calculator gave it to us all after we ran the t interval. So we didn't know the population standard deviation for B. So population standard deviation is what it asked for. No, we didn't know it. C asked if we use Z or T interval. We used a T interval. D wanted to know the interval. We found that. So our interval was from 6.1585 to 7.3165. So that if we put it in a sentence, we can say, I am 97.5% confident that the true mean strength of the fishing line is between 6.1585 and 7.3165 pounds. Okay? I'm going to take this opportunity to be interactive. I used to be sponsored kind of a little bit by Strand. Their 6 pound line's awesome. I have noticed that it pulls in really big fish that are bigger than 6 pounds. Now it's rated for 6 pounds. It says that right on the package, if you can't see it. 6 pounds or 2.7 kilograms for those of y'all that don't use pounds. And they give you 200 yards on the spool. Little sponsorship moment there. Or 182 meters for their people that use meters. Tells you the inches. It gives you all the information here on it. On the actual spool, it comes in a little bag. I really like Strand. Strand's really strong. I use it for my small stuff. I actually use Seaguar Red Label for my bigger stuff. But that's beside the point. What you'll notice here in this problem, it's rated for 6 pounds. Okay? But when we actually go out and test it, a lot of times it's actually stronger than what it's rated for. Now, if you think practically or common sense wise, there's probably a good reason behind that. If you're expecting something to hold up to 6 pound strength, you don't want it to test under 6 pound strength, right? So 6 pound strength line is probably not the average of that strength line, because if it was the average, it was right in the middle, you'd have 50% of the data below it and 50% above it, right? We don't want half of our line to be less than 6 pounds, right? We want most of our line to be able to pull in a fish that's bigger than 6 pounds, okay? For those of you that fish, if you pull in a fish bigger than 6 pounds, you're probably going to want to have bigger than 6 pound line, because fish that 6 pounds can actually pull stronger than 6 pounds, if that makes sense, because you got all that water force behind him and get out in the current. But I will say, Seaguar Red Label does work really well for the bigger stuff. Strand does work really small for the small stuff. That was me in college. That was a 6 pound smallmouth bass on Lake Jocassee, and I think that one was 3.5. I've caught 6 pound spotted bass up there too. Just a second brag on myself, because it's up like 11:15 at night. I'm tired. And I just made you look at my cool clumps and stuff. So it is my YouTube. The school's getting a bar for a little while, so I guess I could throw that out there. If you had a chance to view some of my other videos, I know this is a little aside. This is actually my farming YouTube. I have a fishing YouTube too. If you're really, really bored, cooped up inside, you can go look for it too. The videos are not necessarily PG-13 rated. Some of them are a little worse. I've had to get rid of some of them so that I could actually get a job. Anyways, back to it. This answers this question. Let's go on to the next one. Number 4. The U.S. Bureau of the Census conducted a survey of 5,000 people and found that the mean income for a person with a bachelor's degree was $38,973. It is known from previous studies nationwide that the standard deviation in income for a person with a bachelor's degree is $6,340. Construct a 98% confidence interval for the mean income nationwide for persons with a bachelor's degree. A says list all given quantities. B says is the population standard deviation given unknown. C says are we finding Z or T interval. D says compute the interval. And we will also put this bad boy in a complete sentence on the board. All right, let's go ahead and work through some of this while we're looking at it. We'll put it all on the board here in just a second. All the given quantities, N is obviously 5,000. Your mean is 38,973. Your standard deviation is 6,340, and you want a 98% confidence. B is the population standard deviation sigma given or known. Well, this is what we have to work through in the problem. It is known from previous studies nationwide that the standard deviation in income for a person with a bachelor's degree is 6,340. Okay. This is not our sample standard deviation. It's not from this sample. It's from previous samples, but essentially from all those previous samples, more than one, we have gathered that this is the true population standard deviation. Okay, so this is the population standard deviation. Okay, it's not of the sample that we're looking at, so we're going to treat it as the population standard deviation. Okay, so is the population standard deviation sigma given or known? Yes, it is. It is, so we're going to use a z-interval, right? It also helps that we're interviewing 5,000 people. All right, so let's compute this interval. We've got enough information here. Let's go on and go straight to the calculator, compute it, and then we will put it up on the board. We're going to do a z-interval, stat, calculate, test. Okay, scroll all the way right to test. We're going to do z-interval. We are going to do stats. Got to have to re-highlight that. Now, our standard deviation here was 6,340. 6,340. Our mean here, flashback, 38,973. $38,973. We sampled 5,000 people. Confidence level for this one is 98%. Let me double check that. Yep, 98%. We're going to calculate it. So, z-interval gives us 38,764 to 39,182. And that would be your answer. Let's put it on the board in a complete sentence. Alright, so all the information for part A. X bar, your sample mean is 38,973. Population standard deviation sigma is 6,340. Your N is 5,000. Your confidence level is 98%. Answer to B was yes, we do know our population standard deviation. C, we chose to use this z-interval. D, we found that interval on the calculator to be from 38,764 to 39,182. I am 98% confident that the average income for a person with a bachelor's degree is between 38,764 and $39,182. So, if you graduate, that's what you can look forward to making, if you're lucky. Somewhere between that percent and our amount, depending on the job you do. Some of you are nurses. You'll make a whole heck of a lot more than that, especially if you get down to a good location. Also, you should be filling out the census, or your parents should be filling out the census. Hopefully you're old enough to fill out the census yourself when it comes on by this year. So all that information the census takes up is really, really helpful to the United States for them coming up with these style numbers so we can do studies and stuff. So please don't skip the census, actually fill it out. It's supposed to be census. Remember, we have a definition of a census. It covers everybody. So ideally it's gonna, everybody in the United States is gonna respond in some kind of way or another. So the better you can respond, the better. So be truthful, be honest, and actually fill it out and do it. On to the next one. Before we start example 5, scroll down a little bit further on your notes and you'll see the sample size formulas. So sample size for proportions, P, is N equals Z squared times P times Q all over the mean or margin of error squared. For means, it's Z squared times sigma squared all over the margin of error squared. Now, if you don't know your population standard deviation sigma, you can use your sample standard deviation in exchange for that population standard deviation sigma, right? So, same thing here. If you don't know your true P or your true Q, what you can use is your sample P and your sample Q. It's perfectly fine. Margin of error seems to give people some difficulties. Margin of error is really not meant to be that difficult. Okay, there is formulas to solve for it. Like I said, we're not going to do those formulas by hand. But when you see margin of error in a problem, it should kind of stand out to you. And what I mean by that, let's scroll up. 5 says a sample of cows is is fed a certain type of grain for a 10-week period to estimate average weight gain. What sample size is needed if you want the estimate to be within 1.5 pounds of the true mean with a 98% confidence? Past experience indicates that the sample or that the standard deviation. Past experience indicates the standard deviation is 7 pounds. Okay. What is your margin of error here? Your margin of error is what you want to be within. That 1.5 pounds. Okay. That's your margin of error. That is literally what you put in for ME in those formulas. You will have to use a formula some. But I probably should have put that other one on the proportionate notes, but it just means you have to pay attention a little bit more and put the dots together. So anyways, let's do this example. I'm going to put it on the board. Alright, what we have here is our formula. We've got our information for this problem. Now ME is just your margin of error. I'm going to stress that again. That was 1.5 pounds from the problem. Okay, so let's go ahead and plug that part in. So 1.5 squared. Okay, sigma squared here was 7 pounds. We know that from the problem as well. So I'm going to say 7 squared. I'm going to leave the z squared alone for a second. Now, that z squared directly reflects your percent confidence. It's just the z-score reflected with 95%. And if you don't remember how to find that on the calculator, if you don't know, I'm about to show you that right now. So, if you want to find the z-score on your calculator, go second distribution, go down to inverse norm. Area is 95%. Keep your mean at 0. Your standard deviation is 1. That's the standard normal. Make your tail the center. Hit paste. And it'll tell you it's from negative 1.95, approximately 1.95, or 1.96. Oh goodness, getting tongue-tied. On both of them. Choose the positive one. We're working with the positive one over here. It really doesn't matter if you choose a negative one, because it's squared anyway. That's it. Just choose one, right? They're both the same thing. That's how you find it. Now, if yours doesn't have the center option, you got to play around with it a little bit more. If yours doesn't have the center option, you can use the left option. But remember, to use the left option, what you're going to wind up having to do, you want that 95% to be in the middle. You're going to have to draw you a picture. 95% in the middle means that 5% is left on either side. If 5% is left on either side, then what you'd have to do if you want to find it to the left, what you're going to have to use is either 2.5% or 97.5% on a left call. So that if you did it, you would do second distribution, inverse norm, 0.975, left, paste in, and you get the same thing, right? Or you could also, if you wanted to find the negative one, for some reason, you could use 0.25. But that's how you find it. Alright, now that we have figured out what the z-score is that goes with that 95% confidence, it's that 1.96, I'm going to plug it in. I've got 1.96 squared times 7 squared all over 1.5 squared. Now, you should be able to type this on your calculator pretty simple. That's what I'm going to do right now on my calculator. I'm going to do 1.96 squared times 7 squared divided by 1.5 squared. And you should get 83.66 approximately. So that what I'm going to do here, if I round appropriately, I'll round up to 84 because you can't choose an n. That's a half. So, or 0.66, you can't choose an n that's not a whole number. So my sample size here needs to be 84 for this problem. That's simple. So, like I said, I'm going to post a video this weekend of a Chapter 17 quiz review. Make sure you finish Chapter 18 quiz as well. Stay on top of your stuff. If you have any questions, let me know. I've been trying to get back to emails as quick as possible. But honestly, I've been putting out a lot of tomato plants. I've got a pretty big, I got about a 3-acre farm here that I'm kind of trying to get going for the springtime because I don't know how long this corona is going to last. And it looks like my 2 other side jobs that I was working are not anymore, at least not for the current time. So, man's got to make some extra money on the side. And I like to farm, and I actually do it a lot. So, I might take y'all outside
because this is actually my farm channel that I'm hosting this on, and show you kind of what I've been doing. If any of y'all even care, or maybe you're just that bored enough to actually watch the extra 2 minutes at the end of the video. I might do that on the next video though. So, if you have any questions, let me know. I'll get back to you as soon as I can. I'll try to be really responsive. Other than that, stay on top of your stuff as best you can. And I will see you next time, where we do, I believe next time, we'll do half of chapter 19 and 21.